Hello, so today we're going to be talking about factoring trinomials where a equals 1. Now think about what tri means. Doesn't tri mean 3? So a trinomial has 3 terms, 1, 2, 3. And when we say a equals 1, we're talking about the number in front of our first term. We call that the leading coefficient. If the leading coefficient is 1, okay, we're going to talk about how to factor those. Now, right here, this kind of guides us through an example. I'm going to actually kind of skip over that example, and I'm going to make up my own because you can look at that example for reference. Okay, so why don't we write down this example? So we are on page 9 of our Unit 1 packet, so you can copy down this example towards the bottom of the page. All right, so we're going to do, let's see, we'll do x squared minus, let's say, 2x minus 24. Okay, so when we see here that there's the leading coefficient is 1, I know we don't see it, but doesn't x squared mean the same thing as 1x squared? So when we see the leading coefficient is 1, what we do is we set up 2 sets of parentheses, and we say, well, what times itself gives us x squared? Well, doesn't x times x give us x squared? So we're going to put an x in the first spot in each of these parentheses. Okay, and then you'll hear some people call this the AM method, and this is why. Let's put an A here and an M here. We need to come up with 2 numbers that add to negative 2 and that multiply to negative 24. All right, now, if you have trouble with multiplication, you are going to have to practice your multiplication facts because that's what makes you good at factoring. If you could multiply, factoring becomes that much easier. If you have trouble with multiplying, this is going to be a very, very difficult topic. So you may want to, study your flashcards. I'm sure they have games online you can use, but you have to get your multiplication facts down. All right, so normally I'm not going to do this, but I'm going to do this for the first time. We're going to make a list of numbers that multiply to 24. Okay, so we're looking for numbers that multiply, well, actually to negative 24, but we'll worry about the negative in a minute. All right, so numbers that multiply to 24 would be 1 and 24, 2 and 12, sorry, these are supposed to be commas, 3 and 8, and 4 and 6. Okay, now remember, we're not multiplying to 24, we're multiplying to negative 24. So if they're going to multiply to negative, doesn't one of these numbers in the pair have to be a negative because isn't a negative times a positive a negative? So let's think about which one to make negative. If the 2 numbers are going to add to negative 2, doesn't that mean if they're adding to a negative, we have more negatives than positives? So the bigger number has to be negative. So let's put a negative next to the bigger number in each pair. All right, so now we need to look at these pairs of numbers and say, well, which pair adds to negative 2? And you can see this one on the bottom here, right? 4 and negative 6, don't they add to negative 2? So these are the 2 numbers that multiply to negative 24 and add to negative 2. So we just put them there, and that's it. So it's a positive 4 and a negative 6. So these are our factors. Okay, these 2 factors would multiply together to give you this original expression. And I do want to point out, let me say or, if you had put this in the other order, right, as x minus 6 times x plus 4, that's perfect too. Okay, it doesn't matter what order you have your factors in as long as you have the negative with the 6 and the positive with the 4. Okay, if you can turn to the next page, page 10, I think we're just going to do the even examples on that page, and then you'll take a look at the odd examples tomorrow. All right, so let's take a look at 22. So we see we have a leading coefficient of 1, right? The number in front of the first term is a 1. So we know we're going to set up 2 sets of parentheses. Since this is an x squared, I'm going to put an x here and here because doesn't x times x give us x squared? So we'll put an x here and an x here. And then we're just doing the AM method. We're coming up with 2 numbers that add to negative 19 and multiply to 48. All right, so let's make our list of numbers over here. Now, if you're good at multiplying, you will not have to do this. You will skip this step. You'll just come up with the two numbers that multiply to 48, add to negative 19, put it here and here, and be done. So if you're good with multiplying, this question should take you maybe, what, like 10 seconds, 15 seconds to do? All right? Again, if you are struggling with multiplication, just practice them. You have to practice your facts. That's how you're going to get good at these. Now, for those of you guys that struggle with the multiplication, I'm going to show you a trick in your calculator. If you go to y equals and see how we want to multiply to 48, you can type in the number you want to multiply to divided by x. And then if you go to your table of values, you're going to list any whole number values you see. So your pairs of numbers will be 1 and 48, 2 and 24, 3 and 16, 4 and 12. And when you get to 5, see how there's a decimal? We don't want to include that one. So we're going to skip over that one. Then we have 6 and 8. 7 gives us a decimal value, so we don't want to include that. Then we have 8 and 6. But didn't we already have 6 and 8? So that's how we know where we're going to stop. So I'm going to make a list of all these values on the paper. Okay, so I copied these all down, right? We had 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Okay, now, what we also have to think about here is, although they're multiplying to positive 48, they have to add to negative 19. So we know if they multiply to a positive, they have the same sign. But if they're adding to a negative, don't those signs have to be negative? So what I'm going to do is I'm just going to throw a negative in front of all these numbers. And then once we do that, we'll look at which pair of numbers adds to negative 19. Okay, well, I could see it right here. Negative 3 and negative 16. So I'm going to put a minus 3 and a minus 16. And these are my factors. And remember, if you prefer to write it in the other order, so having the x minus 16 first and then the x minus 3, that's totally fine. These both are equivalent and they both mean the same thing. All right, now let's take a look at number 24. And I think from this point forward, I'm going to skip listing out all of our factors like this. I think I'm going to leave that up to you to do, okay? So we're just going to jump right to it. Okay, so number 24. Now this time you'll notice that there's an x to the fourth, but that's okay. Since our leading coefficient is 1, we're still going to start off the same way. We're still going to set up 2 sets of parentheses. But since this is an x to the fourth, I'm going to put an x squared here and here, because doesn't x squared times x squared give us x to the fourth? Okay, so our first term changes. X squared times x squared is x to the fourth. Okay, so now we're going to come up with two numbers that multiply to positive 24 and add to negative 10. So if you want to use your calculator and do trial and error, you can. But I think a lot of us will probably see if it's going to multiply to positive 24 and add to negative 10, it's going to be negative 6 and negative 4. Okay, these two numbers multiply to 24 and add to negative 10. Now, I just want to point something out because some of you may be looking and saying, well, what about this x squared right here? What do I do about my factors? Well, let me just show you why this checks out just like it is. Okay, off to the side, I'm going to check. This is not part of the problem. If I were to do x squared times x squared, it would give me x to the fourth. And then x squared times negative 4 is negative 4x squared. Negative 6 times x squared is negative 6x squared. And negative 6 times negative 4 is positive 24. And if I did combine my like terms right here, right, I can bring down the x to the fourth. And doesn't negative 4x squared and negative 6x squared give me negative 10x squared? And then when I bring down the 24, look at this. This expression here is the same as our original. So you don't have to put any x's after here. Even though this is an x squared, when I double distribute the first term times the last and the second term times the third, you'll see that's where that x squared comes into play. Okay, now although a lot of times we're done, look at this, right? You should recognize this from the other day. This is a difference of perfect squares, okay, or it's dots. So what happens is we can factor this second factor, I'm changing colors now, further, okay? What we do is we take the square root of the first term, so the square root of x squared is x. We make one of our parentheses plus and the other is minus. It doesn't matter which is which. And we take the square root of the second term and we put that in the second spot in each parenthesis. Okay, so x squared minus 4 factors further to x plus 2 times x minus 2. Now, this is still one of our factors. We don't want to forget about it. So let's take the x squared minus 6 and bring it down because that's part of our answer. So this time, our answer has 3 factors. It has 1, 2, 3. So if you can factor further, you always want to do so. So this is the answer to 24. Okay, we're going to take a look at one more together, and that'll be number 26. All right, so number 26. Now, if you notice here, the leading coefficient is not 1. So whenever you factor, you want to say to yourself, can I factor out a greatest common factor? And look at this. All of these numbers are even. So we can factor out a greatest common factor. Now, since they're all even, it means we could pull out a 2. But see how our leading coefficient is negative? Whatever sign your leading coefficient has, that's the sign we're going to factor it out. So we're going to factor out a negative 2. If this was a positive 2, we'd factor out a positive 2. But because it's a negative, we're going to factor out a negative. And let's put that in our notes. Okay, so everyone write this in your notes. Okay, let's put an arrow to that negative leading coefficient. And it says, if the leading coefficient is negative, you're going to factor out a negative. Now remember, when you factor out a greatest common factor, we only open up one big parenthesis, okay, not 2 parentheses, because what we're doing is we're basically just dividing each of these terms by negative 2. So negative 2 divided by negative 2 is 1, so we have 1x squared, which I'm just going to write as x squared. Positive 18x divided by negative 2 is negative 9x. And then positive 72 divided by negative 2 is negative 36. Okay, so what we're going to do is we're going to be able to factor further. So this negative 2 just comes down. And since this is a trinomial where the leading coefficient is 1, I'm going to set up my 2 sets of parentheses. Since this is an x squared, I'm going to put an x and an x. And I'm going to come up with 2 numbers that add to negative 9 and multiply to negative 36. Okay, so let's see. We would have, you can do the trial and error, you could list things out, but you'll wind up with negative 12 and positive 3. Oh, there's the bell, so I got to finish up. But anyway, negative 12 times positive 3 is negative 36, and negative 12 plus 3 is negative 9. And since neither one of these is a difference of 2 squares or, perfect cubes, we cannot factor further, so this is our final answer.